That
We are live.
that should be us live. Hey, folks! Welcome to another Service Mesh Academy. My name is Jason, and we're joined by my colleague Flynn. Oh, this way, Flynn.
Whatever.
So
Yep.
Flynn, what are we talking about today?
We're talking about Linkerd with external certifying authorities. Specifically, we're going to show off Vault.
Nice.
Should be a good time, I think. Or
Okay.
everything will go horribly sideways and nothing will work correctly, and we'll be very embarrassed. But so hopefully that's not the way it'll go.
Yeah, let's hope it's not that. So, folks, what we like to do is kind of give a minute or two at the beginning for folks to sign up, get settled, talk about where they're from. We got a couple places where you can do this. So we've got a workshops channel over in Slack, and we're going to put the Slack link. There we go, right there. If you join the workshops channel, then you can say hi to folks. Also, if you're on YouTube or wherever else this thing's broadcasting, right, like LinkedIn, Twitch, feel free to say something in the chat over there. The best place to ask questions as we go is going to be over in the workshop Slack, as I'll be there. We've got some Linkerd maintainers over there. If Flynn doesn't have enough to do, he'll also answer questions in Slack. All right.
And if you have general Linkerd questions, you can go to the Linkerd 2 channel on the Linkerd Slack. But the workshops channel is definitely where you want to be for questions about the workshop. So, shall we give folks a couple seconds more to say where they're from and such, and join if they're running late, carry a drink of water?
Yeah, I think that's great. But while they're doing that, Flynn, do you mind kind of just sharing a little bit about what we're talking about today?
Yeah, we are going to be talking about certificate management in Linkerd, but we're going to be talking about certificate management in Linkerd from the perspective of how do you actually set things up and make it work if, say, your corporate PKI people are already running Vault off to the side and they want you to do that. We keep telling people that this is a thing you can do, and then we haven't really gone through and spelled out what it really looks like. So this seemed like a fun time to do that. That's pretty much it. So we'll go through all this in great detail.
Awesome. Can't wait.
If anybody wants to look ahead, this is the source code for the workshop. And that in particular has everything that you will need to kind of go ahead and actually, follow along if you want to, that sort of thing.
Great. And also, if you're in the workshops channel in Slack, you can get that link there as well. Well, you'll be able to get that link there presently.
And I am, of course, pushing the last minute tweaks to the source code for the workshop because I just realized there were a couple. So if you're already looking at it, run git fetch and git pull.
Awesome.
This is how we roll. All right, so let's go ahead and get this going. Yeah, so this is Linkerd with external certifying authorities using Vault. As Jason mentioned, I'm Flynn. I'm a technical evangelist for Linkerd. Jason's also a technical evangelist for Linkerd, but Jason worries more about the sales side of the world, and I worry more about the open source side of the world. So yeah, this is how you can reach me if you want to do that. The best way by far is Slack. I'm Flynn on pretty much all of the Slacks that have anything to do with CNCF or Kubernetes, but the Linkerd Slack is doubtless the best one. And let's go ahead and get this going. So here's the agenda. This is primarily a workshop, but we are going to do a bit of background first. I'm going to do a quick intro to certificates and certificate hierarchies and how identity and certificates work in Linkerd, because this is stuff that seems to be confusing still 30 years after I first ran into it. We're going to do a very quick intro to Vault and Cert-manager themselves, and then we're going to dive into the workshop. For the workshop, you can follow along. You are encouraged to follow along even. GitHub.com, Buoyant.io, Service Mesh Academy. There's a directory in there called Certificates with Vault. That's the one to look at. There are a bunch of things that we're going to use on this. If you've followed along with previous Service Mesh Academies, you probably already have them lying around. But the big ones are, we will be using Kubernetes. We're actually, specifically for this one, we will be using K3D and Docker. And so I should really have made sure that was specifically called out. My apologies. But here's a bunch of stuff that you will need to follow along. Okay, a couple of notes, words from our sponsors before we dive into more of this one. First off, next month, just slightly over a month from today, on October 18th, we have KubeCrash, the fall 2023 edition, where we will be talking about multi-cluster deployments at scale using only 100% open source technologies, which should be kind of cool. It's free, it's virtual, you can sign up at kubecrash.io, go for it. It's pretty cool, actually. It should be a lot of fun. We have the Buoyant Linkerd forum. Slack is a wonderful tool, but everything on Slack evaporates after 90 days or so. And so having things in a forum where you can search them and they'll last for longer than 90 days has been proving to be really helpful. You can scan the QR code or go to linkerd.buoyant.io and get set up there. We also have our Fundamentals of the Service Mesh online course and certification at learn.buoyant.io, where you can go through and learn some things and get tested and get a shiny badge that you can show off on Linkerd. And I think this is the point where everybody should probably mock both Jason and me, because I don't think either one of us has the shiny badge on our Linkerd.
On LinkedIn, and I in fact do have all the badges on LinkedIn. So
okay, well then it's just me who gets mocked.
Right.
Oh
True.
man. Okay. Yeah. Also, if I said you get a badge to display on Linkerd, Jason caught that. You get a shiny badge to display on LinkedIn. I would say that I can't believe I made that mistake, but unfortunately, I can believe it all too easily.
Yeah, I do it all the time.
Yeah. If you haven't heard, we have an enterprise Linkerd distro now, and there are still some early access slots available for that. So if SLAs and CV remediation and SBOMs and cost-aware routing and FIPS and all this are your thing, and they should be if you're doing any enterprise-y stuff, drop William a line on the Linkerd Slack. William Morgan is his display name, and he can get you set up. The last time I did this one, actually, he was on, and so he got to go and pitch that. And next month, October 26th, which is a bit of a departure from our normal date, next month I will be joined by Regina Scott, an Argo CD maintainer, and we'll be talking about Linkerd and Argo and the Gateway API and doing a hands-on demo of all that, which should be kind of cool. So hope to see everybody there. I think that's it for words from our sponsors. Let's get into an intro to certificates. Go ahead.
Just before we go, check out the Argo rollouts SMA, because this is one of the occasions in your life where you're gonna play with the technology and it's just gonna work, and it's really nice.
We really like it when things just work.
Yeah,
that's pretty cool. Yeah. All right. Certificates. A lot of what I'm going to be going over here, you can find in the Buoyant MTLS guide. I would encourage you to go off and read that after the fact. There's probably a little bit much to be trying to read it during the workshop, but yeah. So certificates are a fascinating topic. I first ran into them in the mid-90s, and I am convinced that they're pretty much as confusing in 2023 as they were almost 30 years ago for just about everybody. So this is the quick rundown. Everything that we're going to talk about here is based on public key cryptography, which is also called asymmetric cryptography. This is important stuff because this is the basis for how trust works within Linkerd and actually within lots of other systems as well. The basic idea of public key crypto is, instead of just using a key, you have a key pair. You have a public key and you have a private key. If you encrypt something with your public key, it can only be decrypted with your private key. If you encrypt something with your private key, it can only be decrypted by your public key. The two keys work together. Both are required. And if all you have is the public key, it is impossible, in air quotes, to recover the private key from just the public key. Impossible in crypto always means computationally infeasible. It is still computationally infeasible. For the things that we sling around in Linkerd, you're talking about hundreds of years of effort. So, we'll just call it impossible. You get a couple of cool properties out of this one. The first is if Alice encrypts something with Bob's public key, then Bob is the only one on the planet who can read it, because since she encrypted it with Bob's public key, you have to have Bob's private key to decrypt it, and Bob is the only one who should have his private key. Likewise, if Alice encrypts something with her own private key, then she's the only one who could possibly have written it, because she's the only one who has her private key. This might seem like an odd thing to do, but in fact, this is extremely common in most crypto systems. It's common enough that the operation of hashing some data and then signing the hash with your private key has a special name, which is signing. And this is a very, very common way to prove that this particular piece of data was generated by this particular person or other entity. So what we get here with those two operations is, first, we get safe communication, because we can encrypt with the receiver's public key and only they can read it. But we also get authentication, because we can sign with the sender's private key and only they could have sent it. And all of this works even if Alice and Bob have never communicated with each other ever before. So this turns out to be the thing that MTLS relies on for basically everything it does. And this is also the thing that Linkerd relies on for authentication and identity. To make this work, there are two things you have to get right. The first one is you must keep private keys private. They form the basis of identity. If Jason manages to steal my private key, Jason can pretend to be me. That's obviously a very bad thing. So keep your private keys private. On the flip side of that one, public keys can and should be just spread around everywhere, because you need to have the public key to verify the signature made by a private key. So it's very important to scatter these things to the four winds so that you're able to always verify who sent you something. The challenge is that actually keeping track of all the public keys and everything like that is a pain. And this is where certificates come into play. A certificate is fundamentally just a data structure that associates a subject, which is a name, with a key pair. Formally, these are X.509 certificates. That's the standard that lays all of this stuff out. Go read it if you have a really unbreakable case of insomnia. It's not much fun. But in this particular certificate that I have shown in this graphic, we can see it has a subject. Its subject is the common name identity.linkerd.cluster.local. That's a special name, actually. That is the name that the identity issuer certificate in Linkerd must have. We'll come back to that in a bit. It has some subject public key info. It's showing you enough about the public key that belongs to identity.linkerd.cluster.local that you can do interesting things with it. It also has up top there the issuer. It's showing us that the issuer's common name is root.linkerd.cluster.local, which is the special name that goes with the Linkerd trust anchor. And at the very bottom, we see information about the signature being made by the issuer. All of this information is public. There's nothing at all in the certificate that is secret. It is always safe to throw certificates around everywhere you want to. The whole reason for that signature also is that way you can prevent the certificate from being spoofed. If you have the public key for root.linkerd.cluster.local in this case, you can verify the signature and you can guarantee to yourself that, oh yeah, this certificate was actually produced by the trust anchor. I can trust it. It's good. Finally, although we're not really going to talk about this much in this particular workshop, there is an axiom in cryptography and security that says that the longer you use a given key, the more valuable it is for an evildoer to break that key. So a really important way to keep things safe is to not use a given key for too long, the operation of changing out the key pair of a certificate is called rotation. It is critical. If you go look at the earlier certificate management SMA, then we get much more into that whole thing. Jason, you have any questions so far? It's always fun to put Jason on the spot every so often.
No,
Questions?
no, this is really good
Comments?
info. It's making a lot of sense. Thanks.
Okay, cool. All right. That deal with you having the issuer and the subject and all that means that certificates naturally exist in a hierarchy. At the top of the hierarchy is the thing that we are going to call the root CA certificate. CA here stands for certifying authority. A CA is an entity that can issue certificates. Back in the bad old days, the CAs were companies that would charge you lots and lots of money to get certificates. And these days, it tends to more often just be software that you're running or that somebody in your organization is running. The root to CA cert is interesting because it is always a self-signed certificate. Its subject and issuer are the same. It signs itself. The reason for this is if there were anybody who signed this one, well, it wouldn't be the root, would it? It would be relying on trust from somebody else. So ultimately, there is always a self-signed certificate to serve as the root of the trust hierarchy. That root CA you can then use to sign intermediate CA certificates, which you can go on to sign leave certificates. You get a hierarchy. There's no particular reason that there has to only be one intermediate CA. You can actually have a chain of however many you want. And of course, an intermediate CA can generate multiple leave certificates. Now, an interesting thing about this hierarchy idea is that a given application may or may not actually need to go all the way up the chain. So a given application could just decide that, hey, this middle intermediate certificate, that's good enough. As long as that one says that everything is okay, I'm going to trust that the rest of the chain is taken care of. In that case, that middle intermediate CA is acting as the application's root, and it can go through and sign CAs and do all the things. We actually use this concept in Linkerd, where from Linkerd's perspective, we have a root that we call the trust anchor, which creates a thing that we call the identity issuer, and the identity issuer issues workload certificates, which go to your actual workload pods running inside a Linkerd mesh. And that boundary, instead of being just some arbitrary applications perspective, the boundary is the boundary of your Kubernetes cluster. So from our perspective today, and from the perspective of the Linkerd docs, and from really a great many perspectives dealing with Linkerd, we're going to talk about the trust anchor as if it were a root CA certificate. But it's useful to realize that it doesn't have to be. It could in turn be signed by somebody else. All right. Any other questions? Any other comments?
No questions so far. Looks like we're sort of still rolling along.
Yeah, I'm gonna have to tell Jason to be rougher with the questions on these. There's a problem. Jason has seen this before, so yeah. All right. We are also not going to talk about this much in this workshop, but I want to mention it here. In addition to the certificates that I was just talking about that are used for Linkerd's workloads and used to handle identity for MTLS in Linkerd, there are also webhooks in Linkerd, and webhooks have their own certificates. Typically, like if you just go and run Linkerd install and you get this stuff, you will get webhooks that are self-signed certificates. Webhook certificates that are self-signed, I should say. This does not have to be the case. The webhooks can be signed by other certificates. And in fact, all three of the webhooks could be signed by the same webhook anchor. There are two things I want to point out here. The first one is don't use the Linkerd trust anchor as the webhook anchor. It will definitely function. You won't get any screaming errors or anything. But from the perspective of security, it's generally not a good idea to mix security domains like this. The webhook world and the MTLS world for Linkerd are very, very different functional domains, and so they should have different anchors. The other thing that I'm going to point out is, like I said, we're not really going to talk about this for the rest of this presentation, but you can take the things that we are talking about for the rest of this presentation and extend them easily into having Vault do a webhook anchor for you if you want to do that. All right. So let's do a quick intro to Vault and Cert-manager. Vault, officially Vault by HashiCorp, lives at vaultproject.io, and its blurb says, quote, manage secrets and protect sensitive data with Vault. Vault is open source, but I'm sad to report that it is not a CNCF project. This makes us all very sad, and I don't know, we should go and talk to the HashiCorp people about that or something. Anyway, a very basic function of Vault is to be a safe place to store private keys and other sensitive data. But an interesting thing that Vault can also do is that Vault can act as a certifying authority. If it holds a secret key, you can ask it, hey, please use this thing to generate certificates for me. And that's how we're going to be using it today. Specifically, we are going to be running Vault such that if you look at our Linkerd certificate hierarchy here, we're going to pack up the trust anchor inside of Vault and never, ever let it get out. Now, the actual way that things have to happen to do that is kind of complex, which brings us to Cert-manager. Cert-manager is by Venafi. If you've been around Cert-manager for a while, you might be used to hearing JetStack, but JetStack was acquired by Venafi, I don't know, 2-3 years ago. On Cert-manager.io, the Cert-manager website talks about, quote, X.509 certificate management for Kubernetes and OpenShift, end quote. Cert-manager is a CNCF project, yay, which we're happy about. And Cert-manager is all about really the fact that distributing and rotating certificates is a pain. And so Cert-manager tries to automate that to make the pain go away. We like things that make pain go away, so we kind of like Cert-manager. You don't have to use Cert-manager with an external CA like Vault. You can have it do its thing completely inside of a Kubernetes cluster for you, but it is most powerful when paired with an external CA. And it's also, that's the most secure. So the way we're going to do this is we have our trust anchor over there in Vault, and then we're going to have a Kubernetes cluster running Linkerd and Cert-manager. And you will recall that Linkerd needs an identity issuer. All right. Here's the way it actually works when Cert-manager goes to get an identity issuer set up for Linkerd. First thing, Cert-manager generates a key pair for the identity issuer. In this case, I'm showing the private key with a gray key, and the public key is the gold key. Next up, Cert-manager takes the public key, very important. It bundles it up into a thing called a CSR, a certificate signing request, which it then hands over to Vault. Vault looks at the CSR, goes, oh yeah, this is cool, and we'll talk a little bit about how it knows it's cool. It then takes the trust anchor, uses that to sign the CSR and produce a certificate, which it hands back to Cert-manager. Cert-manager then puts that in the right place for the identity issuer, or rather the right place for Linkerd to see it as a certificate for the identity issuer, and then Linkerd can use it to generate workload certs. You do not want to be doing this crap by hand. It's a royal pain. This is the reason why Cert-manager exists. There are two other things I want to point out here. The first critical one is if you look carefully at this diagram, you will realize that that gray key never ever leaves the Kubernetes cluster. And you'll also realize that there's nothing with the trust anchor that leaves Vault. That is a deliberately shown detail that mirrors the real world and is very important. Private keys should never ever leave the thing where they get used. The other thing that I'm going to point out is that we're actually going to be using both Cert-manager and an auxiliary Venafi project called Trust-manager. And we'll talk more in detail about that. At the level of this diagram, there's no real difference between Cert-manager and Trust-manager.
So I have a question for you, Flynn.
Hit it.
Imagine just the hypothetical that something like Vault, goes from open source to being closed source, or some.
Oh, that would never happen, dude. What are you talking about?
Let me finish. And I want my external store, right? Because I want the add security of not keeping my trust anchor inside my Kubernetes cluster,
right?
But I'm not using Vault. Do we have other stores that we can use?
Yeah, there's a slide where we there's a slide later where I will include the link for where you can go to find out about this. Cert-manager can work with a very large stack of different external issuers. Vault is an obvious one. Cert-manager works with Acme, so you can use it directly with Let's Encrypt if you want to. You can, there are a couple of different Venafi projects. There are 2 or 3 different Venafi projects, I think, that you can use Cert-manager with. Those are probably not going to help you very much if you're getting away from Vault because it's gone closed source, because those are proprietary, but they're pretty cool anyway. There's a stack of things like various Googly projects and Amazon sorts of things and stuff like that it works with.
Each cloud provider likely has their own certificate store we can work with.
Yep.
Okay.
Yeah. The reason that we're picking on Vault in this one is that it is open source, but also, actually, I think the next one is the demo architecture. Whoops. All right. Can you hear me, or did I accidentally mute myself?
I hear you. Yep.
Okay, good. Clicked the wrong button. Thought I muted myself. This is actually a pretty good time to go into the workshop architecture, because this is why we're using Vault for this workshop. Once again, this is exactly the same slide from before. These are all the things that you need to use to follow along, and I hope you do follow along. The way the demo actually works is we start by running Docker, which probably everybody has on their machine anyway. Inside of Docker, we're going to run 2 containers. Our first Docker container is going to have Vault in a Docker container. Please note, I did not say a Kubernetes cluster, a Docker container. In the second Docker container, we're going to run a Kubernetes cluster with K3D. In our Kubernetes cluster, we will run Linkerd and we will run Cert-manager. And we're also going to arrange it so that our 2 Docker containers are on the same Docker network, which makes it possible for Cert-manager to speak over that Docker network to Vault. This is the real reason why we're doing this with Vault, is that this setup can be done entirely on your laptop. I'm going to be running all of it on my laptop, and it's fairly straightforward to set up. Some of the bit when we go set up Vault, you'll be looking at going, this is straightforward, but that's okay. You know, there's a bunch of stuff that's kind of just boilerplate from our perspective, where you can just step through the steps and you'll be good to go. This is not a workshop on the care and feeding of Vault. This is a workshop on how to set things up so that Cert-manager can talk to Vault. In Vault, we will have our trust anchor, and then we're going to show how to use Cert-manager to get the identity issuer from Vault and let that set up so that Linkerd can do workload certs. We will also be configuring Vault by talking to it from the Vault CLI running on the host network on the laptop itself. And this kind of mirrors a real world scenario where it's pretty common to have your production network be separate from your administrative network that you're going to use to go through and, you know, talk to Vault or talk to your crypto system stuff. So that is why we are using Vault. And part of the reason, for those of you who happen to not be aware of this, part of the reason for Jason's totally hypothetical question was that HashiCorp actually did recently change the licensing on a bunch of their products. And that's a little interesting and raises some questions. But for now, yeah, still good to go using Vault. So we're going to do it that way. Does that answer your question, Jason? Do you have any other questions?
Not right at the minute, but I'll keep thinking of them.
So I don't see any questions in Slack or on chat, which either means that we've been doing a great job of explaining everything, or means that everybody's eyes are hopelessly glazed over because nothing is making any sense at all. I hope it's the former, but if any of y'all on the workshop channel want to chime into that effect, that would be nice. With that, I think it is demo time. I'm going to have to modify this slide to have crossed fingers on it somewhere. Okay. So let's get this show on the road. Once again, I hope that's readable. Looks okay. Once again, we're going to be showing the use of Vault, but we're not going to be really teaching the care and feeding of Vault. It is worth noting, I forgot to mention this earlier, there are a lot of, especially larger enterprises out there, larger companies, that will already have an external PKI infrastructure that the security people want you to use. And so that's another reason for showing this off, is that it's actually fairly common to be running Linkerd and have an external public key infrastructure setup that you're going to need to use. And so this ties in nicely with that. All right. So this description we already went over. We're going to be running Kubernetes in a K3D cluster. We're going to be running Vault in Docker. Those two are going to be on the same Docker network so they can talk to each other. And the nice thing about all this one is that you can just run it on your laptop and everything is happy. So off we go. Step one, I'm going to make sure that I don't have an old cluster lying around. And then I'm going to recreate a cluster. This K3D command may look kind of ugly. It's actually not that bad. This bit is all about mapping ports 80 and 443 for K3D's load balancer back through to my local host network so that it's easier for me on my laptop to talk to services in the cluster. This bit is setting the name of the network we want to attach to. And this bit is turning off a bunch of stuff that we don't need, because I am running this on a laptop. I don't really want to be running a bunch of stuff that we don't need to have. So off we go with that. The port mapping part of that's a little bit ironic because I'm actually not going to be running any services in this cluster for this workshop, but yeah, whatever. It's there anyway. And there we go. So we can talk to our network or talk to our Kubernetes cluster. That's great. And now we can fire up Vault. This is an extremely ugly command. And so we're going to break this one down step by step. Docker run is the way you start a container running in Docker. Shocking, I know. -- detach. When you run Vault, it normally spews out a whole bunch of stuff on standard output. We don't need to see that. I don't want to mess around with background processes. I just want to tell Docker, start the container running and just don't bother me with it, okay? If I need the logs, I can run Docker logs to get them. -- rm, -- name Vault. When this container dies, remove it, call it Vault. We need to know the name because we're going to have to find it by name later. -p 8200 8200. Vault listens on port 8200. I mentioned earlier that we were going to be using the Vault CLI running on my laptop to talk to Vault to configure it. That means we have to have access to that API port. So that's why we're mirroring that port back. Same network parameter to put it onto the same network as the K3D cluster. And I'm not even going to talk much about this cap add. Turns out Vault really wants the IPC lock capability, so we give it to it. Great. Next up, the image name is HashiCorp Vault, and then we're going to run the server command. We are going to cheat and run the server in development mode. And the reason we're going to cheat and run it in development mode is that if you don't run it in developer mode, you have to go through a lot more hoops to set it up, and it's just not relevant for what we're doing here. Everything in the way that we're configuring Cert-manager works the same. So -dev is developer mode. -dev listen address tells it, in particular, telling it 0.0.0.0 means bind to all of your network interfaces. Don't only listen on localhost. If we don't do that, then it's fairly difficult to, well, again, we have to go through extra hoops to make it so that the K3D cluster can talk to it and the host network can talk to it. Dev root token ID effectively sets the password that we will use to authenticate the CLI to Vault. We are going to set it to the incredibly strong password my-token because, it doesn't really matter for this. The other thing I should probably point out is that when you run in developer mode, you get to talk HTTP to Vault instead of HTTPS, which all by itself should be a great reason to never ever run in developer mode in the real world. All right. Once again, we're going to make sure there's not already a Vault container lying around, and then we will fire up the Docker container that we want running Vault using exactly the command that we had above. Okay, so we're going to set the shell variable vault adder to http://0.0.0.0:8200, which is what we just told Vault to listen on. If you don't do that, you have to repeat that for every Vault command, and that got boring really, really quick when I did it that way. Vault status, oh good, it's running. It's not running in HA mode. It's is storing things in memory, other really good reasons why you don't want to do this in production. So off we go. All right, we have Vault running. We now need to authenticate the CLI to Vault so that we can go through and set up a few things in Vault. Vault login, we give it the MyToken password. I'm sure they have a reason for calling it a token, but I don't know what that reason is. The next thing we have to do is tell Vault that we are going to use it to do PKI things. PKI stands for public key infrastructure. You can use this either in the relatively loose way that we are using it right now to mean we want to do public key things, or in the relatively strict way of following a whole slew of standards. And that is why we have to explicitly enable it, because Vault doesn't want to mess around with it if we don't need to. So we shall enable it. That's great. We're also going to tell Vault that when people come in and ask for certificates, they are not allowed to ask for certificates that last any longer than 90 days. As with so many things in the Kubernetes/Go ecosystem, we cannot talk about days for durations. We have to talk about hours. So 90 days turns out to be 2,160 hours, which is why we are doing that. There's a question on chat. Integration with the EKS secrets manager. We'll come back to that. There's a link that I'll show later to some Cert-manager documentation that should get into that, because that's going to be the critical thing. Jason, if you happen to have that lying around off the top of your head, then you know.
Yeah, we'll send that Dimitri over in the workshops channel if you don't mind hopping in there.
Yep. So there you go. We have tuned the secrets engine to only allow 90-day leases. Great. And again, all of this stuff is boilerplate, setting up Vault. If you were using a Vault being provided by, say, your corporate security people, they will have already done all this. And it will just be a question of being told what sorts of things you need to know about it. But if you want to play with it on your own, you can just go through and run these things and it will work. This next bit is always a little bit strange to me, but it basically boils down to Cert-manager is going to expect to use particular URLs talking to Vault, and so we have to tell Vault that it should honor some of these things. Great, done. Finally, I mentioned earlier that Vault was going to get a CSR from Cert-manager. Vault will then check the CSR, decide that everything is okay, and carry on. One of the big reasons that Vault can know this is okay is that we're going to configure Cert-manager to present a magic token to Vault so that Vault knows it should be able to trust Cert-manager. Those tokens are associated with things that Vault calls policies, and that I tend to think of as kind of being analogous to roles in the Kubernetes RBAC sense. So what we're going to do here is create a role which is just kind of allowed to do anything with PKI. And again, the corporate security people will have set this up differently. They will probably not give you a token for a super user role, but you know, for our purposes here, this is fine. And for their purposes, you would end up going through and saying, hey, I want to connect Cert-manager to this Vault. Please give me the right token. They would give you the right token and you wouldn't have to think too much about policies. So we'll create our super user policy there, and then we will get, but not display, a token for that policy. All of these things like this Vault write command, we're not really going into a lot of detail about them. You can go look up the details on some of these just by typing Vault write help or Vault help, those sorts of things. But I will point out that this -field equals token thing, normally if you do a Vault write, it gives you back this whole slew of crap, and a lot of it is things that we don't need to save. So if you're trying to reproduce this by hand later and you forget that -field equals token in there, things will be a little bit more confusing. And of course, I don't know that from personal experience. Never at all. Okay. So we've gotten the token, we've saved it in an environment variable so we can use it as we set up Cert-manager. This is the vault setup done. Jason, anything you wanted to chime in here? Okay. Once again, in practice, if you're dealing with a vault being set up by somebody else, the somebody else will have done all this crap and you won't really have to think very much about it. The last thing we're going to do here is tell Vault to actually create our Linkerd trust anchor. And this is the sort of thing where who does this in the corporate world? I would expect it's probably the corporate security people, but depending on how it goes at a particular organization, this might be something you have to worry about and it might not. So I decided to leave it as a separate thing after all of the boilerplate vault setup. A couple of important things here. And even if somebody else is doing it, you're still going to have to tell them this information. In this case, we are storing the Linkerd trust anchor itself directly in Vault. So we tell it, this must have a common name of root.linkerd.cluster.local. It must also be an elliptic curve key, which is key type equals EC. The lifetime is up to you. We're setting it to the maximum 2,160 hours because we know that's the longest lease we can, or the longest TTL we can get from this particular vault. So we will do that. This is the path that you tell Vault Write to do this. We pass the common name, root.linkerd.cluster.local. We give it the TTL, we give it the key type. And again, we only want it to show us the certificate, the public piece that's okay for everybody to see. If you leave that off, it's not going to reveal the private key, so that's good, but it does throw in a bunch of junk that makes it harder to use this later. So we do that, and we're going to use step certificate inspect to make sure that we actually got a meaningful certificate here. And the answer is, it looks like we did. So we have a subject of root.linkerd.cluster.local. The issuer is the same. We have the key stuff. It is a CA, which is good. Its subject key and authority key look to be the same values. This looks like it should be fine as a Linkerd trust anchor. Okay. Now, let's go ahead and get Cert-manager installed. I'm going to go ahead and start that running before asking if Jason or anybody else have more questions, because Helm installs always take just long enough for me to be afraid that they've died before they finish. So yeah, Jason, any commentary or heckling or questions?
No heckling, right? Just want to reiterate, right? Like the expectation here is that whatever your secret manager is, you're going to follow that JetStack Cert-manager documentation around the integration. And like the expectation, every organization is different, right? But the expectation is that this secret store is some central store provided by your infrastructure team or security team.
Now, in small organizations, the team that is running Linkerd and the team that is running the corporate secret management could in fact be the same single person. So, in small startups, you may be in for a lot of reading about how your secret store works, but the basics of how we set this stuff up and integrate with Cert-manager, the integration with Cert-manager is covered in Cert-manager's docs. So, it is definitely doable. Okay, we now have Cert-manager going, and we want to also use Trust-manager, which is the other project that I mentioned. What's happening here is that Cert-manager is going to generate certificates that it stores in Kubernetes secrets. But best practices in Kubernetes are that unless there is some secret information, you shouldn't use a secret. So for the trust anchor, where the only thing Linkerd needs access to is the public key part, that should not go in a secret. That should go in a config map. So we're going to use Trust-manager to copy the relevant information out of the secret that we get into the config map. And this is what Trust-manager does. Interesting thing about Trust-manager It's not allowed to read secrets from anywhere in the cluster that it wants. When you set up Trust Manager, you tell it a trust namespace. And it is only allowed to read from the trust namespace. And by default, it will also write things into the trust namespace. Since we want Trust Manager to be messing with things that Cert-manager will create for Linkerd's use, we are going to tell Trust Manager that its trust namespace is the Linkerd namespace. That means we have to create the Linkerd namespace, because if you try to install Trust Manager and point it at a trust namespace that doesn't exist, it gets very unhappy, and that does not work. So first we will create the Linkerd namespace, and then we will install Trust Manager using this particular set command to set the trust namespace to the Linkerd namespace. All right, that's all done. And we can take a look and see in the Cert-manager namespace. Oh, I'm sorry, I should have mentioned that explicitly. We are installing Trust Manager into the Cert-manager namespace, but we're having its trust namespace be a different one. So in the Cert-manager namespace, we can see a bunch of things running for Cert-manager. We can see Trust Manager running. This looks like it's working correctly. Okay. Now we get into kind of the good stuff, which is how do we actually configure Cert-manager to talk to Vault and do all of the things that Linkerd needs? The first thing for that is we need that token. You remember the token? We created it 15 minutes ago. So we're going to take that token and we're going to store it into a secret, a Kubernetes secret in the Cert-manager namespace, in order that Cert-manager can use it to authenticate with Vault. So that's done. We're not actually going to look at the data there. Part of the point has been to show that we don't need to ever see this stuff. If we really wanted to do this safely, we could actually do this whole thing as one pipeline. And yeah, the token would exist in RAM briefly, but that would be it. But we will at least describe that secret and see, hey, look, there's a key called token, and it has some data in it. So that seems like a good sign, right? Next up, Cert-manager needs to talk to Vault to have Vault issue certificates. And the way that you configure Cert-manager to issue things is you use a Cert-manager issuer resource. There's a thing called an issuer, which exists within a namespace, and there's a cluster issuer, which is cluster-wide. We are going to go through and create a cluster issuer that will allow us to go back to Vault to get the identity issuer certificate issued. Wow, that was very confusing. Linkerd has the trust anchor, and there's also the identity issuer certificate. We are going to use a Cert-manager cluster issuer resource to describe to Cert-manager how to ask Vault to issue a certificate that Linkerd will use as its identity issuer. Don't you just love naming in this world? It's always so unambiguous and clear. To actually create that cluster issuer resource, we need the access token, which we just saved in a secret. Very good. We need the address of the Vault server. And we also need the path that we're going to use to ask Vault for new certificates when we go and talk to Vault. For Vault, if you look at the documentation, you will find that this is pki/root/sign intermediate. So very good. But we do not yet have the address of the Vault server. We cannot use 0.0.0.0 because that would refer to the pod that Cert-manager is running on in the Kubernetes cluster. What we actually need is the IP address of Vault's Docker container on the Docker PKI network. And we can use Docker inspect to get that. This is why we needed the name. We needed to set the name of Vault because we use it here. I would strongly encourage y'all to go and separate the elements of this pipeline and see what you get back. But basically what we're doing is we are asking Docker for all the details of the PKI network, which happens to include all the containers that are attached to it. We are using JQ, the JSON query language, to go and grab the containers map out of the first array entry, and then we turn that into an array, and then we select the array element that has a member named name whose value is Vault, and then from that we grab the element called IPv4 address. And for the record, I love JQ. It's very powerful, and oh my god, I would love it even more if stuff like this was straightforward, which it is not. The IPv4 address actually shows up as a CIDR thing because it's talking about a network, a chunk of the network being assigned to a container. Containers can have multiple IP addresses. We only need the IP address, so this is find the first field if we split that line into something separated by slashes. And if we run that, we will find that Vault is running at 172.28.0.5. Given that, we can stick the IP address into the cluster issuer YAML. So the way this works, this cluster issuer is named Vault issuer because it's issuing things from Vault. This Vault key in the spec is what tells Cert-manager, hey, use the Vault logic. This sets the URL path that we talked about. This sets the server address. And since we're in dev mode, we are indeed using HTTP, not HTTPS. And this provides the name of the secret that we wrote the token into for Cert-manager so to authenticate itself back to Vault. Let's go ahead and apply that and then find out what happens. Okay, so we have a Vault issuer, cluster issuer, but most importantly, it shows as ready and it says it has actually been able to verify access to Vault. So think about that for a second. We have a Kubernetes cluster talking to a Vault that is not in the Kubernetes cluster, even though it's all running on our laptop. Occasionally, modern technology is really, really cool. Next up,
quick reminder for folks out there, do check your K3D version just to make sure that it's fairly recent if you're having any issues with installing the charts.
Ooh, that's a good point. I had not checked that because I tend to keep K3D up to date as a matter of course. Yeah, mad props to Eliza for catching that one. Yeah, that I think I'm actually using 1.27 right now, and we'll shortly be switching to 1.28 now that it's out. Okay. Any other questions or comments on that, Jason? Okay.
No, not at the moment.
One of the things that is pretty potentially confusing about all of this is that some of the nomenclature is so weirdly overloaded, and you end up with, issuer showing up in so many places with so many different contexts. Unfortunately, that's something where the best advice I can really give is to read carefully, then reread carefully and think about what you're looking at. But I can promise you that as I was going through setting up this demo, there were a great many times where I looked at something and initially thought I was looking at something else because the naming was weird. Okay, after we set up the cluster issuer, we need to set up a certificate resource to use it, because the certificate resource is the way we tell Cert-manager which certificates to generate using that issuer. So this is a certificate named Linkerd Identity Issuer. Important note, this lives in the Linkerd namespace. This must live in the Linkerd namespace because Cert-manager won't issue a certificate in a namespace other than the one where its certificate resource lives. So when this gets a certificate, it's going to write that certificate into a secret named Linkerd Identity Issuer. This is important because that's the secret name that Linkerd wants to find its identity issuer in. We're going to ask it for a certificate that lives for 48 hours. We're going to make sure it gets renewed less than halfway through its lifespan. We are going to use our Vault issuer that we just created a minute ago. And when we go to ask that issuer to issue a certificate, we are going to tell it to use the common name identity.linkerd.cluster.local, which again is the name that Linkerd requires for its identity issuer certificate. The rest of this is kind of boilerplate. It's typical to set the DNS names to the same as the common name. I don't think it's necessary, but it's common. It must generate as a CA cert because Linkerd will use this to issue our workload certs. It must be CDSA, and this is basically saying, do the things that you would expect a certifying authority cert to be able to do. So we'll issue that. And the next thing we're going to do is use a bundle resource to tell Cert-manager how to copy the information that Linkerd needs in the trust bundle out of the certificate being issued. The way this works is the name of the bundle. So first off, bundles are cluster scoped. They're not namespace scoped, so it doesn't really matter what namespace this goes into. The name of the bundle is the name of the config map that will be written. And what we're telling it here is, hey, Cert-manager, look into the secret named Linkerd identity issuer. Grab the thing with the key ca.crt and write that into a config map named Linkerd identity trust roots under the key ca bundle.crt. All of these are magic names. Cert-manager, when it issues a certificate, politely puts the public key of the issuer into the secret under the key of ca.cert. When Linkerd goes to try to figure out, to look in the Linkerd identity trust roots config map, it will look at the ca bundle.crt key to find the public keys of the trust anchors that it should consider valid. So all of these, the names must match up. If you try to edit this very much, it will break and it will not work. So we're going to go ahead and apply that. Anything to add before we see if it worked, Jason? Nope. All right. Let's see if it worked. So
really just don't poke around and change things unless you have a good reason to, unless you know what you're doing.
Yeah. There are a lot of places where you can pretty much do whatever you want and call things whatever you want, but this is not one of those places. So we can see that in the Linkerd namespace, we have a certificate named Linkerd Identity Issuer. It is ready, and it wrote to a secret called Linkerd Identity Issuer. Great. We can also see that we have a bundle here. Excuse me. We have a bundle that also says it is synced. It is ready to go, all that. So that looks good so far. That is just what Cert-manager has to say about things, of course. The next question is, does Kubernetes actually show the information we need? So we're actually going to go dive under the hood and look at some of these things. And I will warn you ahead of time, if we do this just by spewing the whole certificate out with step certificate inspect, it chews up a lot of space on the screen and can be kind of difficult to read. So instead, we're going to use this fairly awful looking shell function to strip that down and only show a fingerprint for the subject and for the issuer, and to show the common name of the subject and of the issuer. And for the curious, you can tell step certificate inspect that you want it to do JSON output rather than its allegedly human readable output. When you do that, it will show up with several different stanzas. One of them, extensions, contains a key ID for the subject and for what step calls the authority and the rest of the world calls the issuer. So we can grab the key IDs for those things. The key IDs are just fingerprints. It doesn't mean a whole lot. So we can grab those two things, limit them to 16 characters to make them a little bit more readable. And there's also a stanza for the subject DN and the issuer DN. DN, in this case, stands for distinguished name. We are really not going to go talk about X509 distinguished names. The point, though, is that since we are looking at the distinguished name, what we will get back will actually start with CN equals, because a common name is only part of a distinguished name. We did these just so this line isn't ridiculously long, but we're using those as string interpolation selectors for JQ to spit this out in a nicely formatted way. So there's our shell function. Now, we're going to look into the identity trust roots config map. We're going to use JSON path to grab the ca bundle.crt key out of the data stanza, and then that will actually be an X509 certificate that we can feed directly into step certificate inspect or into our inspect cert function. And if we do that, we see that the issuer and the subject both have the same key and the same name, because it's a self-signed certificate named root.linkerd.cluster.local, which is exactly what we want to see for the public half of the trust anchor in Linkerd Identity Trust Roots. Now, we can repeat this exercise looking into the Linkerd Identity Issuer secret. It looks mostly the same, The differences are, first, the secret has 3 keys. TLS.cert and TLS.key are the public and private halves of the actual Linkerd identity issuer certificate. And Cert-manager helpfully puts the issuing certificate's public key into a key called ca.cert. The other thing that's weird is that in secrets, there's an extra layer of base64 encoding thrown onto these things. So we have to use kube control get secret with JSON path to pull out the key we want. Then we have to pass it through base64-D, and then we can pass it on to step certificate inspect. Yay. If we do that, we will see that our identity issuer, the subject, has a common name of identity.linkerd.cluster.local, which is what we want. The issuer is root.linkerd.cluster.local. The key of the subject and the issuer are different, and the key of the issuer matches the key of what we got from the trust anchor out of the Linkerd trust bundle. Trying to get all the names right while talking about this is difficult. But in this case, this is a demonstration that, yes, we have a non-self-signed identity issuer cert, and it was actually signed by the trust anchor that we generated in Vault. Also very good signs. There's a question for source code of the demo in a GitHub repo. Absolutely. I will try posting that directly here, but I don't know if it's going to work. Oh, wait, I don't have to try posting it. I can go over and turn the caption back on. There you go. There's the source code for you in GitHub. All right. I'll leave that up for a minute since it doesn't seem to be getting in the way of anything. Also, just for the fun of it, we can look at the ca.cert key in the identity issuer secret, which should be the same as the one we found from the trust anchor bundle, right? And if we do that, yeah, same keys, same self-signed thing. This is all looking good. Okay. Next up, thank you, Jason, for putting that link into the workshops channel. I shall go ahead and take this down now.
And so at any point, folks, if you're watching over on YouTube or any other place, if you head over to slack.linkerd.io and join our workshops channel, you can get all the links and stuff there. Thanks, Lynn.
All right. So at this point, we have what we need to actually install Linkerd. It only took us, what, an hour to get here? So we will use Helm again for this because why not? And the first thing that we do with Helm is we install the Linkerd CRDs chart to get the Linkerd CRDs. And then next up, we will use Helm to install Linkerd's control plane. Couple of very important flags here. First off, actually, I guess there's 3 very important flags. We need to install Linkerd in the Linkerd namespace. Remember that we already created this, so we don't have to tell Helm to create the namespace. But these next 2 are really important because these are the way you tell Helm, hey, something else is managing the identity issuer and the trust anchor bundle, and you do not have to go mess with this. Linkerd does not need to go mess with this. Everything should already be in place. Identity.issuer.scheme tells it that the identity issuer certificate is in place. Identity.external.ca tells it that the trust bundle is also already in place. If you do not use those flags when you have Cert-manager set up, I think what happens is that Cert-manager and Linkerd end up trying to fight with each other about who owns the certificate, and it gets ugly pretty quickly. Jason, do you know exactly the details on that?
I don't know.
Well, Eliza, if you have something that you wanted to chime in on the workshops channel. The short version is, don't do that. That is bad. So we will do it this way, which is the good way. And we will now let Linkerd check run, which will both wait for everything to get started and, perhaps more importantly, check over all of our certificates to make sure that everything is happy. Not found page error. So we are seeing a report that the URL is incorrect, which...
I've got it. I'll handle that.
Okay, thank you. Eliza says, I would agree with the suggestion of not doing that. Excellent. Always good to hear. Okay, Linkerd check has finished. That's always nice. If we scroll up a little bit, we can see, hey, look at this. All of this stuff shows up valid except for one warning. And the one warning there is saying, oh man. Okay, so I'm gonna fix this broken caption just to make sure that we get it correct here on the video. Certificates with Vault, not certificates in Vault. I'd like to apologize to everyone for my inability to deal with prepositions in my native tongue. Yeah, man, that's embarrassing. Okay, so backing up to something that actually worked. Linkerd check here is telling us everything is valid about our certificates with one complaint, which is that it's complaining about the issuer cert not being valid for at least 60 days. And the reason for that is that we deliberately told it to get an identity issuer cert that was valid for 48 hours instead of 60 days. There's actually, I think, a longstanding issue for being able to tune this warning, and that would make me very happy if we get around to doing that. Okay, so far so good. That is actually the end of the workshop. We're at the point where we could go and install workloads into the mesh, and we could do all your usual meshy things. But the point of this is talking about certificates with Vault, not, Linkerd and workloads. So we're going to stop here. I want to reiterate the critical point that Vault is not running in the cluster, and the trust anchor's private key never ever left Vault. You can't get it if you only have access to the Linkerd cluster at all. It is not there. It is not possible to get it. That's kind of the point of this, is to be able to, to have things like this where the secrets are kept separate from everything else. And that's the reason that we go to all the hassle of doing things like this.
Just to hammer on this a little more, right? Like, you don't want to keep all your eggs in one basket. Don't keep your trust anchor in the Kubernetes cluster with your service mesh. And if you're looking to do service mesh in a multi-cluster fashion, right, you need multiple clusters to be talking to a single trust root, right? And an external certificate key store makes that all a lot easier, right? Like, I think we could say officially, right, like Buoyant recommends that you use Cert-manager to rotate your certificates no matter how you're doing Linkerd, right? Or some automated process to rotate your certificates. And using an external store for the root is definitely the best way to do this, right? And then we've got the docs over in the workshop channel for all the different providers that you have. And I'll tell you, the JetStack folks, or formerly JetStack folks, now Venafi folks, are awesome. They're happy to update Cert-manager to work with whatever tool it is. It's something that I've been using basically as long as I've been in Kubernetes, right?
Yeah. I'll reiterate that the JetStack. Damn it! Now you got me doing it. The Venafi folks, the Venafi formerly JetStack folks, they've been great to work with. We've done a fair amount of work with them, both with Linkerd itself, but also with the KubeCrash conference as well. So,
on that note, you have a KubeCrash plug for us?
You should go join KubeCrash and register for KubeCrash. And KubeCrash is awesome. Let me put that up. KubeCrash Fall 2023. You can find do all the registration stuff at kubecrash.io. The last time we did KubeCrash in the spring, we did a joint demo where we had 4 different products all collaborating to do a single zero trust reference architecture. This time around, we're going to have 4 or 5, I don't remember exactly how many, collaborating on a single multi-cluster at scale demo, which should be kind of fun. We're also breaking new ground this time. Our demo app is actually stateful. And so we're going to have stuff living in a database, which is either going to be, it's going to be really cool. Let's just go with it. It's going to be good. Yeah. Never done that one before. Yeah, there's once more in the text there, the link to the Surface Mesh Academy doc or sources. Quick note, we already talked about the external stuff. And with that, yeah, I should have put the Kube Crash slide here as well. But next month, October 26th, normally we do this kind of on the third Thursday, but Kube Crash happens. So we're going to do this one a week later. That will be Linkerd Argo and the Gateway API with Regina Scott. Come one, come all. That should also be a good time. Yeah. And other than that, we have a little bit of time still for questions, comments, heckling, whatever.
I have no time for heckling.
Well, okay, fine. Questions and comments then. I see somebody typing in Slack, but I don't see other stuff. There we go. Yeah, so question there about the integrating with AWS and...
Yeah, I'll send that over right now.
Yeah, cool. But we can bring this back up again for the Cert-manager external CA stuff. And in the workshop channel there, Jason just helpfully posted a link for using the AWS private CA issuer, which is a thing that Cert-manager just supports, which is great. Yeah, it's especially great. It's especially great because that way I don't have to figure out AWS.
Yeah. Hey, I guess that's really the beauty of Kubernetes for me. All right, folks. Thanks so much for attending. Really appreciate all the questions.
Oh, we do have one more question. Chris Randall asks if we're using token auth between Cert-manager and Vault because it's preferred or for simplicity. Kind of both. Jason, were you gonna jump in?
I was gonna say, I think we'll tell you the best way to authenticate between your services is gonna be with a TLS certificate. So if you're doing it, if you have whatever choice you want, right? X509 is the way to go.
Yeah.
Tokens easiest though.
So yeah, let me back that up a little bit. Kind of both in the sense that it is easiest for the demo and it works it definitely works if you don't have the ability to go through and set up something like certificate auth or whatever. Some of the other ones, like you can authenticate with a service account, but that gets weird if your Vault isn't in Kubernetes. So, I probably wouldn't recommend that one. I think there's a way to turn auth completely off. I would definitely not recommend that one. So, yeah. Going through and setting things up so that your Vault, and sorry, let me back up another moment. We were running Vault in dev mode here, which meant that we were talking to it with HTTP, not HTTPS. That is 100% so that we don't have to go through and set up all the work of getting a TLS cert for Vault, which we would have to do some other way than getting it from Vault to be really useful. If you do that one for real, you give your Vault a TLS certificate, you set things up so that Cert-manager knows how to validate that, which requires knowing the issuer hierarchy, the CI hierarchy for the cert that you got for Vault. Then you can set up another certificate that you can use to authenticate Cert-manager to Vault. And yeah, it's a little tricky. But again, if you're doing this in the real world, probably all that's going to be handled by somebody else. And you can go to your corporate CA people and go, hey, I need a certificate, please, for my Linkerd installation. And they go, great, here you go. And even that's going to be a little bit more involved because they're going to ask you to generate a secret key and then generate a CSR and do all this stuff. So yeah.
I use Cert-manager, so whatever whatever you need.
Yeah, there are times where the certificate management aspect of the world really gives one the sense of it just, oh, it's turtles all the way down and there's no bottom, and it gets a little bit weird.
Yeah.
Yeah,
Right.
because like Jason, it's not like you can use Cert-manager to get the certificate for Cert-manager to use to authenticate itself with Vault from Vault, right?
It's true. That's true.
You gotta do that one by hand.
Yep.
All right. Okay, well, I think we're done then, since I'm not seeing any other questions. Let's go on here. Once again, that's how you reach me if you need to, or at Flynn on all the Slacks everywhere. Please don't ask me how many Slack workshops I have open at any given time. Just don't. And we will see y'all on the 26th of October for another one of these. Thanks much.